Hello and welcome back to this video series of higher chemistry calculations. This video is going to be on different types of gas molar volume calculations. The first type of molar volume calculation or question that you might come across is in the multiple choice questions, and here you might have a question like this that says what volume of gas would be produced by the complete combustion of 100 centimetres cubed of ethane gas. So here we have ethane gas burning in excess oxygen to give us carbon dioxide and water. So the first thing you have to do is identify the chemicals that the question is asking about. So it's asking us about ethane gas, so we can highlight that, and it's asking us about what volume of gas would be produced. Water here is a liquid, so we're ignoring that and we're only then looking at our one gas that's produced. So let's rewrite that down here. So we have 2 moles of ethane gas would produce us 4 moles of carbon dioxide gas. So it's going to be a 2 to 4 reaction. You can keep that at this point, or you can simplify it down to a 2 to 1 mole reaction. Then what we are going to do is, we know from the question we have 100 centimetres cubed of ethane, so we can substitute that moles in for volume. So 1 mole equals 1 volume. This time our volume is 100 centimetres cubed. If 1 mole gives us 100 centimetres cubed, then 2 moles must give us 200 centimetres cubed. So your answer for this one would be A, 200 centimetres cubed. Let's look at a similar type question. Here we have another question that says 20 centimetres cubed of butane is burned in 150 centimetres cubed of oxygen. It gives you the balanced equation, and you're asked what is the total volume of gas that is present after complete combustion of butane. So the important thing to note here is that it's asking you for total volume, so you have to include all the product gas that is produced and also any excess gas that is not used up from a reactant side. So first things first, I'm going to rewrite my equation down here. So I've got 1 mole of butane, my 6.5 moles of oxygen, give me 4 moles of carbon dioxide and 5 of water. Okay, now this water is in the gaseous phase here. If that was a liquid state symbol, we would obviously not be including this. Okay, so I've got 1 mole to 6.5 moles. Okay, so in the question it tells me that I'm using 20 centimetres cubed of butane, and we're using that figure to work out the ratios for all the others. So we have 20 times 6.5 or 6.5 to work out our volume of oxygen that we're actually using, so that's 130 centimetres cubed, and then 20 times 4 gives us 80 centimetres cubed, and 20 times 5, which gives us 100 centimetres cubed. Okay, so we're substituting this 20 in the place of 1 mole, so that's where those numbers come from. Now we can then see that our gas produced was 80 plus 100 centimetres cubed, which gave us 180. Okay. But we also have excess gas, right, for our reactants. Here in the question it told us that we had 150 centimetres cubed of oxygen, but we are only using 130 in a reaction, so you need to work out how much excess gas you have left over. 150 minus 130 gives you 20 centimetres cubed. And then to work out your total gas, you are doing your excess gas plus your gas that was produced. So here we are going to have 200 centimetres cubed of gas, and that is going to therefore be answer D. In paper 2 of the higher chemistry exam, which is the written answer section, you will see a different type of molar volume calculations. A good way to work these out is to use a formula triangle like we have in previous years. So here at the top we have our V for volume, and that's the volume that we have in our reaction. N, again, same as before, this is our number of moles that we are using, and our last piece goes to Vn, or sometimes might be heard of as V mole, and that is our molar volume. Now, in the vast majority of these questions, the molar volume is given to you, it's stated in the question, so you are simply substituting in whatever value they have given you, which is usually 24 litres per mole. To work out these type of calculations, there is an easy 4-step method to use. So step 1 is to work out your ideal mole ratio. Now, when we talk about ideal mole ratio, what we're actually saying there is how many moles are in the balanced equation. Step 2 is to actually calculate the number of moles for one of your chemicals in your equation. So step 2, calculate the number of moles. In step 3, you are going to work out the actual, or the kind of real life mole ratio, which obviously uses step 2. And for step 4, you're just answering the question. So is it asking you for volume? Is it asking you for mass? Answer whatever the question has asked you to do, and usually at this step, this is when you would be using this triangle. Let's have a look at an example of this. So here we have an example of a molar volume question worth 2 marks. So it says copper reacts with hot concentrated sulfuric acid to produce sulfur dioxide, and here we have our balanced equation. We've got copper plus sulfuric acid giving us copper sulfate, sulfur dioxide and water. It says calculate the volume in litres of sulfur dioxide gas that would be produced when 10 grams of copper reacts with excess concentrated sulfuric acid, and it says take the molar volume of sulfur dioxide to be 24 litres per mole. So the first thing to do is, in this balanced equation, highlight the 2 chemicals that you're interested in. So we're looking at copper and we're looking at sulfur dioxide, and I'm just going to read out these down here. Now we have step 1 was your ideal mole ratio. In this balanced equation we have 1 mole of each, so it's a 1 mole to 1 mole ratio. That would be step 1. Step 2 would be to work out the number of moles of one of these species. So we have mass for copper, so we can work out the number of moles of copper. So over here, number of moles is, like from Nat 5, we're just doing mass divided by gram formula mass. Okay, so we're going to do 10 divided by the gram formula mass of copper, which is 63.5, and you should get a number of moles as 0.157. Oh. So that is the number of moles that we are of copper that we're actually using. Okay, so in a perfect world where we're just dealt with balanced equations, we'd be using 1 mole of copper. In the actual lab, we're using 0.157 moles. Okay, so then we go back. Step 3 is our actual mole ratio. So here we substitute this figure up and we say we're actually using 0.157 moles of copper, and since it was a 1-to-1 ratio before, it's the exact same, it's still a 1-to-1 ratio, so we are actually using 0.157 moles of, we're actually producing 0.157 moles of sulfur dioxide. Okay, now step 4 is answer the question. What is the question asking you to calculate? Calculate the volume produced. Okay, so if we look at our triangle, asking us to calculate the volume. So we're going to have to do the number of moles times the molar volume. The number of moles you've just worked out is 0.157, and the molar volume is given to you in the question as 24 litres. Okay, so we're going to do that, 0.157 times 24, and you will get an answer of 3.768, and rounding we could say 3.7 litres. So our volume of sulphur dioxide produced is 3.7 litres. Let's have a go at another one of those. Okay. So here it says nitrogen dioxide can be prepared by heating copper to nitrate. We've got our balanced equation. Copper to nitrate decomposes to form copper oxide, 2 nitrogen dioxide and half a mole of oxygen. Calculate the mass in grams of copper nitrate required to produce 3.6 litres of nitrogen dioxide, and it says take the volume of 1 mole of nitrogen dioxide gas to be 24 litres. So first things first, let's identify what we're looking at again. We are calculating the mass of copper nitrate that produces 3.6 litres of nitrogen dioxide. So these two we're interested in, and let's just rewrite this down here. Okay, so this time we have a 1 mole to 2 mole ratio. And we are given information about our nitrogen dioxide gas. We are told that we're using 3.6 litres. So again, just for now, you obviously don't need to keep drawing out this triangle once you've got the hang of it, but we can for now. So we know the volume is 3.6 litres. We know the molar volume, 24, so we can work out the number of moles. Okay, so we can do 3.6 divided by 24, and that will give us a number of moles as 0.15 moles. Now again, here was our ideal mole ratio. Here we have calculated the number of moles, and we'll go back to step 3, put it over here, to show that we're going to work out our actual mole ratio. So this is a 2 to 1 reaction, but we don't have 2 moles, we've only got 0.15 moles in the actual world. So we're going back the way. This just means cross multiply, and what that essentially means is we're just doing 0.15 moles multiplied by the opposite side, so multiplied by 1, and then divided by the number that is on the same side. So we're going to do that, and that works out to be 0.075 moles of copper. Okay, so there we have worked out our number of moles of copper. Now, step 4 is answer the question. What does the question ask us? It asks us to calculate the mass. Okay, so now we need to work out mass. The same as we've been doing for years now, mass equals number of moles times gram formula mass. You've just worked out the number of moles, 0.075, and then you need to input the gram formula mass. Now, hopefully we all remember how to do that. We should have been doing it for quite a few years at this point. I'll just pop my working here. Okay, so we get, 187.5 grams, and we're just going to plug that into this calculation up here, and when we work that out we should get 14.0625, which we can of course round to 14.1 grams, and that is the answer for that question. Now we are going to look at some molar volume questions that I've pulled from previous SV exam papers, so that we can see how those questions are kind of formulated and how they're written in the exam. So here it says hydrogen peroxide decomposes to form water and oxygen, gives us a balanced equation. A dishwasher tablet produces 0.051 grams of hydrogen peroxide, which the mass of 1 mole, i.e. the gram formula mass, is 34 grams. Calculate the volume of oxygen that would be produced when 0.051 grams of hydrogen peroxide decomposes. Take the volume of 1 mole of oxygen gas to be 24 litres. And this is worth 3 marks. So the first thing that I'm going to do is, again, I'm going to actually select on the balanced equation which chemicals I'm interested in. So that's my hydrogen peroxide and my oxygen. And then I'm going to rewrite that down here. I can see that that is a 2 mole to 1 mole ratio in the ideal world based on our balanced equation. Now, step 2 would be to calculate the number of moles for one of these chemicals. So looking at the question, it tells me a mass of hydrogen peroxide and a gram formula mass. So over here I can work out the number of moles of hydrogen peroxide. So my mass is 0.051 and my gram formula mass they have worked out for me. They're saying it's 34. So I'll do that division and I will get a number of moles of 0.0015. Okay, that then comes across here as step 3, our actual mole ratio. We can see we have 0.0015 moles. Ideal world it's a 2 to 1. Actual world it's a 0.0015 mole to 0.0015 times by 1 divided by 2. And you should get 0.00075 moles. Or it might be shown on your calculator as 7.5 times 10 to the negative 4 moles. Okay, you don't need to have this written down as both, you can write it down as either or, and that is accepted in your working in chemistry. Now, we're on to the last bit, step 4, which is saying answer the question. It said calculate the volume of oxygen. So using our triangle again, volume, number of moles and molar volume. So volume equals the number of moles times the molar volume. Our number of moles we have here. Our volume from the question is 24. And once you've plugged that into your calculator, you should find you get a value of 0.018 litres. So our final answer for 3 marks is 0.018 litres. Let's have a look at another exam style question. Here we have a slightly different style question. It says methanol can be used as a fuel in a variety of different ways. Okay, it gives us the full structural formula and says an increasingly common use for methanol is as an additive in petrol. Methanol has been tested as an additive in petrol at 118 grams per litre of fuel. Calculate the volume of carbon dioxide in litres that would be released by combustion of 118 grams of methanol. Take the molar volume of carbon dioxide to be 24 litres. So just here at the side, I'm just going to pop my triangle down so I've got it for later. I'm going to have a look at my question. I'm going to identify what the two species are that I'm interested in. So I'm interested in the carbon dioxide, we're interested in the methanol. Let's rewrite those. It's a nice 2 mole to 2 mole ratio. So a nice easy one, we can collapse that down at the beginning. It can be a 1 to 1 ratio. Okay, and now we have to calculate the number of moles that we actually have of one of our chemicals. Okay, so it tells us that we have 118 grams per litre of fuel, of methanol. So that's our mass. We can do number of moles equals mass divided by GFM. So we have 118 grams of methanol. Oh, and we need to work out the gram formula mass of methanol. So it's giving us 32. So we do 118 divided by 32 and we should get an answer of 3.6875. Round that to 3.69 moles. So then if we substitute our actual number of moles up here in our mole ratio, it's a 1-to-1 ratio. So if we've got 3.69 moles on this side, we're going to have the exact same number on this side, 3.69 moles of carbon dioxide produced. Now we answer the question. So looking back here at our molar volume triangle, we want to figure out the volume, so we're going to do the number of moles times the molar volume. The number of moles we've just worked out, we said it's 3.69, and our molar volume came from the question, so 3.69 times 24, and that should give us an answer of 88.56 litres. And that is your final answer there for 2 marks. Okay, let's have a look at one last past paper style molar volume question. You may want to pause this here, pause the video, attempt this calculation on your own at home, and then replay the video so that you can check that you've got it right. Okay, we can mark it as I go along explaining it. So if you want to try this one on your own, pause the video now, work your way through it, and then come back to me in a few minutes. Ooh. Okay, let's continue. Calculate the mass in grams of carbon dioxide that is produced by combustion of 200 centimetres cubed of methane in excess oxygen. So again, first thing I'm going to do is select what chemicals I'm interested in my balanced equation. So it's my methane and my carbon dioxide. It's a nice and easy one. It is a 1 mole to 1 mole ratio. Okay. Here it says I've got 200 centimetres cubed of methane. Now remember, 1 mole is equivalent to 1 volume. Here our 1 volume we're going to say is 200 centimetres cubed. So if I'm putting in 200 centimetres cubed of methane, I am getting out 200 centimetres cubed of carbon dioxide. Okay, now again we're going to use a triangle. Okay, this time we have our volume, and we have our molar volume, gives us in the question. So here we're going to use the triangle differently this time to work out the number of moles of carbon dioxide. So number of moles is our volume divided by the molar volume. So we've got 200 centimetres cubed. Let's convert that into litres. So that's 0.2. So we're going to do 0.2 litres divided by 24 litres. And that is going to give us 0.0083 and a whole load of 3's recurring. So we're just going to say that is 0.008 moles. Okay, now we're going to have to use, one of our older formula triangles. Okay, because it's asking us to work out the mass, and we now have the number of moles. We have the gram formula mass, or you can work out the gram formula mass. Oh, in fact, they give you in the question gram formula mass of carbon dioxide. So we're just going to do mass equals number of moles times GFM. We've got our 0.008 moles that we've just worked out, and that is times by 44.0 grams of carbon dioxide, and we're going to get an answer of 0.352 grams. Obviously you can round that to 0.35 grams. So our final answer there for 2 marks is 0.35 grams of carbon dioxide are produced. And that is the end of this video on higher molar volume calculations, guys. If you find these videos useful, make sure you subscribe to the channel, turn your notifications on, and you should be able to see when new calculation or new chemistry videos go live, and hopefully they will continue to help you. Good luck with your exams.